I think Sridhar and Amrita are going to be presenting today, but I'll be your local pretend person to sit up front and not do anything because it's their presentation. But I'm from the same team. So a quick introduction. We'll have Sridhar Samudrala and Amrita Nambiar presenting today from Intel, and I bet they'll introduce themselves a little bit too. But if somebody needs a mic run around, I'll come help.
Hi, this session is on Netlink APIs to expose Netdev objects. I am Amrita Nambiar. My colleague Sridhar Samudrala is also involved in this work. We'll go over the agenda. So we will be discussing configuring net devices. We'll also discuss the configuration interfaces. Our focus will be on the YAML Netlink interface. Specifically the Netdev journal interface, and we'll look into configuring queues, NAPI, and page pool via the Netdev journal interface. And we'll also talk a bit about generic queue management. Configuring net devices. So we know NetDevs are becoming complex. More functionalities are being added, and the configurability is also getting improved. There are a large number of net device features, and there are multiple interfaces to configure these features. Ideally, what we need is a stable, generic, and scalable API, and this should be able to keep up with the complexity. This could be used for user controllability, and having such strong generic models in the kernel would abstract away driver specific implementations. So we could avoid code duplication. We could avoid major differences between vendor implementations and such. Uh, Moving on, some of the NetDev properties. So it is possible to do device configuration from the NetDev for multiple properties. And here are some to name a few. This could be related to queue management and their queue level properties. It could be NAPI parameters. It could be stats, RSS, such as hashing, context handling, interrupt moderation properties, flow steering, traffic shaping, rate limiting related, offloads like GROTSO, USO, checksum, VLAN stripping and insertion, XTP properties, zero copy header data split, which could be per queue or per queue group configurations, and logging and debugging related, um, like the NetDev or driver dumps and attestation, scaling related, ARFS, XPS, and such, tunneling or link information, link configuration. So the point is, there are a lot of properties that can be controlled from the NetDev at the NetDev level. And we do have interfaces to configure these NetDev properties. And these are standard upstream APIs that are currently being used by multiple vendors. And these focus on three main aspects: the functionality itself, that's enabling and disabling, performance related, as in specifying parameter values or ranges or other feature specific user configuration. Then debugging related, like reporting the um, uh, diagnostic data, dumps, etc. And for these purposes, we use interfaces like TC, Devlink, eTool, SysFS, NetFilter, IP, Bridge, socket options on the net device. Um, so, we do have these interfaces, but then the high configurability issues persist. And these issues are not something new, or they are not specific to NICs alone. So we have seen high configurability issues in other products like Kubernetes, OpenStack, and the way it's addressed there uh, is by means of targeted plugins, or specific plugins for specific features. So we extend our learning from there and um, conclude that it may not be possible to provide a one true interface for all of net device configuration. What we could best work with are targeted APIs, uh, feature specific targeted APIs, and the orchestration layer in the user space would have to combine these. And then there is the Netlink interface. So, the path we are taking forward for new features is the Netlink interface. So, the Netlink interface for net devices could be a useful candidate in future. Um, so, these new features are nothing but attributes of the net device Netlink object. Um, So let's take a deeper look into the YAML netlink, which is already available in kernel. The vision with YAML netlink was this should avoid developer involvement in netlink coding. And YAML netlink provides netlink libraries that are closer to being truly generic, as in very minimal changes are needed to support a new family or a new operation uh, uh, from the developer himself. Um, so what is needed is one should define these netlink messages and attributes in YAML, and the code gen would then output the kernel and user code meant for doing parsing, validation, documentation, etc. So today in the kernel, we have YAML specs for uh, few subsystems like the Netdev YAML, DPLL YAML, eTool Devlink, Handshake, OVS, configuration, etc. So the details are in the kernel documentation, um, but a quick ramp. So the kernel uses these YAML specs to generate the CU API headers. The documentation is also generated as a REST file, and this could also generate code for policy tables and doing initial validation, operation tables, and the compatibility is with the generic Netlink family. Um, and a quick look into using the YAML Netlink. So the kernel comes with a Python Clyde tool. This Clyde tool works with the YAML spec to issue Netlink requests to the kernel. Now, the tool itself takes some arguments. The spec file is one. Then there is a request name as do or dump, and the input set in JSON format, and a notification group or a subscription group. Um, the kernel code is generated using a Python script, and so there is the YNL library, which is a libmnl based C library, and this works with the Python code gen and creates the Netlink wrappers for the kernel. Now let's focus on the YAML Netlink for NetDevs. So Netdev General is the generic Netlink interface for configuring net device features, and this uses the Netdev YAML spec. The request types supported are get and set currently for Netdev General, uh, though mostly it's get requests, and we don't have set requests from the user space yet, but it's possible to support via notifiers. And the operation types supported are do and dumb callbacks. So if a do callback is uh, done with the get command, this would retrieve information about a certain lookup key. And if we use the dumb callback, uh, we could retrieve information for all the net devs, or you could even do a filtered dump with a certain net dev alone. And mm, for the set request, if you do a do callback, you could do modifications or changes using this. Now, currently, the NetDev Journal is used by XTP, so this exposes XTP features and XTP RX metadata like the hash, the timestamp. Now we have some patches in the upstream mailing list for exposing other NetDev objects. So work is in progress for the queue, NAPI, and page pool NetDev objects. So let's take a look into queue configuration. Uh, so the goal here is that we should have a queue object in the uh, a queue object, and this could be used for queue configuration in the core. So having this in the core simplifies a lot of stuff. So it helps doing a lot of prep work or validations in the core. This would simplify modifications and reconfigurations in the driver, and it would be simpler to export configurations to the user. Now, the patches that are work in progress exposes only very basic queue parameters, like the queue index, the queue type as RX, TX, or XTP TX, and the interface index of the net device to which the queue belongs, the NAPI ID or the NAPI instance servicing the queue. Uh, it should be possible to support more queue attributes via the queue object. And to name a few, stats, ring size or descriptor number, header data split for RX0 copy. So this could be per queue configurations. Um, an example is um, we should be able to disable header data split for a queue that's the AFXTP queue. Um, then page pool ID. So it should be possible to associate page pool to a queue. And this is useful as in the memory model could be exposed this way. So um, you could expose configurations like DMA buff, whether it's a kernel buff or a user buff, and NUMA node binding for the queue. That's if the NUMA node is the default device NUMA node for the queue, or if it's the app NUMA node itself, um, that kind of information. Then the RSS context handling. So from the user space, we should be able to map the queue to a particular RSS context group, and this helps in container use cases. And then for XTP, exposing XTP TX queues instead of having to uh, configure them default in the driver itself. Um, Looking into NAPI configuration. So here the NAPI instance is the Netlink object, and the NAPI attributes that could be exposed are the NAPI ID, the interface index of the net device to which the NAPI instance belongs, um, then the interrupt number associated with the NAPI instance, the process ID of the NAPI thread. Uh, so there are patches upstream that exposes these attributes. And in future, we also plan to extend further and support polar timeout as an API attribute. Now, this serves some use cases like adjusting the NAPI thread priorities and SMP affinity, uh, configuring NAPI polos to queues from the user space. So this could be used to limit the number of NAPI instances. So we could configure a polar to multiple queues sharing the same interrupt vector. And then moving on to page pool configuration. So there are patches upstream in the mailing list by the maintainer to expose page pool parameters via Netlink. Um, and some of these are the page pool instance ID, the interface index, the NAPI ID for the NAPI instance using this page pool, then some memory usage information like the reference count, the bytes held, etc. The page pool stats. Um, and in future, it's possible to add more extensions uh, like the DMA buff configuration for the page pool or the NUMA node binding for the pages. So these could be page pool configuration parameters from the user space. Uh, so so we believe that these three net device netlink objects that we have seen, the queue object, the NAPI object, and the page pool object, these three could work together to serve a larger purpose. And we think that's where the community is headed. That's generic dynamic queue management APIs. So this should allow creation of queues without a full device reset. And there are some semantics here that needs to be figured out. Um, like if the are the QIDs sequential, or are the QIDs provided from the user space? Are holes supported in the QIDs, etc. Now, um, so at the end, we should be able to support creating additional queues, but then the existing queues should continue to transmit and receive. And this should align with multiple models. So there is one model where there are process specific queues without zero copy, and this might repurpose existing queues, mostly related to container use cases. And then there are process specific queues from user space with zero copy that mostly allocates or frees memory from the process itself. And then there are the default driver queues for normal network traffic. Um, and towards this goal, there are some requirements that should be achieved. So We need the queue object that maintains the expected configuration, even though the queues are created by the driver itself. And then page pool configuration should be supported from the user space, though page pool itself is created by the driver. It should be possible to associate DMA buff with a page pool, and then finally associate queue with a page pool. Uh, so these are some example APIs. So in the mailing list, we have mostly get commands and get commands for queue, NAPI, and page pool to expose some basic queue parameters, NAPI parameters, and page pool parameters. And um, in future, we plan to introduce set commands for queues so that uh, so that we could associate existing queues with the NAPI ID from the user space. Now, if at all a queue create command comes into being, um, we plan to create queues bound to NAPI ID, although the semantics here still needs to be figured out. Um, so to summarize, we have Netdev that are becoming more and more complex, and the even though it would be ideal to have a generic scalable API for net device configuration, the best we could work with are targeted feature specific APIs, and and Netlink interface for net device configuration is also suitable. Um, we also visited Queue, NAPI, and page pool configuration via the Netlink interface as Netdev objects. Thank you.
Maybe the question can go into the chat. My question is merely, do you have APIs to the underlying queue disks in the wireless interfaces? David, you going to ask that for me? Cool.
Anyone else got a question? Amrita? They may be responding in the chat.
Should I just ask?
Just go ahead. I'm going to be on the recording. Maybe they'll hear you. I'm not sure.
Okay. For the IDPF driver, I'm wondering whether per queue configs and bringing down and bringing up individual queues and creating individual queues on the fly, is that something difficult to do, or does it extend well to these Netlink APIs?
Yeah, I think she tried to answer you there. You see, these APIs should be applicable to the Netdev. Any other questions? Looks like we have a couple chats going on in the chat. You guys are welcome to finish that. I think we're about out of time for this session anyway, so we're going to move to the next one. Thanks, Amrita and Sridhar, for that presentation. Sorry for the technical difficulties, everybody, but we're just rolling with it.